Good morning, guys. As today we are starting through the Diploma of Electrical Engineering, the syllabus for semester 2 for Fundamentals of Electrical Engineering as per MSBTE course code 312310. Now we are going to learn the Unit 1 basic electrical parameters, and accordingly I will teach you the DC current, direct current, alternating current AC, voltage source and current source, and their ideal and practical, electrical current, electrical potential, potential difference, electromotive force, EMF, electrical work, electrical power, and electrical energy, definitions and their expressions, resistance, resistivity, conductivity, effect of temperature on resistance, types of resistors and their applications, heating effect, magnetic effect, chemical effect of electrical current, and so on. For the first unit 1, we have to at least cover it in 2 or 3 lectures in our upcoming videos. Now we are going to start with it. Hello guys, let's start with today's lecture on fundamentals of electrical engineering. As shown on board, we are going through Diploma in Electrical Engineering, same to subject fundamentals of electrical engineering. The course code is 312310. Now I am Saurabh Survasi, the tutor, the owner of eSpark Tech Academy. Now, yesterday I have gone through my introduction, and still now we are going through the curriculum of Diploma in Electrical Engineering. Now, starting with Unit 1, Basic Electrical Parameters. Now, as per the syllabus, now we will go through 1.1, which is direct current DC, alternating current AC, voltage source and voltage source ideal and practical, and current source ideal and practical. First of all, what is direct current? DC current. Direct current, the current which is constant throughout throughout the given voltage. You can indicate it through a waveform as voltage taking as base and current on y-axis. Now the DC current is constant for various values of voltage. Even if you are taking a specified voltage values on this x-axis, still you will be go through plotting of this map or waveform, which will be constant throughout. Now we can say it as current flows only in one direction, because you are seeing this as it is in only one direction. Now we will be going through our second point, which is alternating current. Alternating current is nothing but a bidirectional current. In positive and negative way of sinusoidal wave, you will be seeing the AC voltage. The AC voltage example is our household AC 230 volt AC voltage. It will be shown in the manner positive and negative half of this sinusoidal waveform. This is a sine wave of input AC voltage. This is nothing but a bidirectional current. Now you will be going through voltage source. What is voltage source? Voltage source is a device that provides constant voltage. Now, as per mentioned in your syllabus, the voltage source are of two types: ideal voltage source and practical voltage source. The ideal voltage source will be acting as internal resistance as zero. The voltage always remains constant even if you increase your load, as it is not possible, actually it is not possible practically, because ideal system does not exist in practical. Still we will be studying this. Now actually any voltage source means it may be DC or it may be AC. This is DC voltage, this is AC voltage. Now even from the symbolical representation you can identify this is positive and negative DC, and this is alternating voltage, sinusoidal waveform itself. It is showing the sinusoidal waveform. Now ideal voltage source. Ideal voltage source is nothing but a voltage source with resistance in series. Resistance in series with the internal resistance, means it will be having this internal resistance Ri with the voltage source, and this Ri should be equivalent to 0 for ideal voltage source. But in practical the internal resistance will be equivalent to some finite low resistance value in milliohms. And same what the practical voltage source will be existing with. This is the ideal condition and this is the practical condition. As we can say that there is no system which exists in an ideal situation or ideal condition. Practical voltage source will definitely have a finite low resistance in series with that voltage, means very low resistance will be there. Now if you are dealing with current source is nothing but current source will be in this direction, resistance in parallel with it, and here we can see the load is been connected. This will be Ri, the internal resistance, this will be the current in the specific direction. In this case the ideal situation for voltage for current will be infinite resistance, internal infinite resistance for ideal current source. And for practical current source, practically in current source it will be in mega ohms or higher value of Ri, which will be in parallel as shown in the figure. Now you will be dealing with electrical current. In 1.1 you will be dealing with electrical current as per syllabus. We will be dealing with electrical current, electrical potential, potential difference and electromotive force. Please note down these parameters. Now I will be explaining it. Now first of all, what is electric current, or what is the current actually? Current is nothing but movement of electrons in any conducting body or in any kind of metal or element through which electrons are moving. Electrons won't move without any force. If you apply some kind of potential difference, as I will show you, when this is a load and this is a source, it may be voltage source and this will be the current flowing through it, and R will be the load. Now we will see that how the current flows. When you apply this kind of potential difference or a kind of voltage, or you can see it as a force applied to a element, this is nothing but a load element. In this load element, when you apply a certain voltage, then current will flow through it. This current, you can say that the device that provides constant current is called constant current source. Or in electric current is nothing but a flow of charge per unit time. You can say I will be Q upon T. Q is nothing but a charge which is flowing for a period of time. Charge per unit time. Charge is nothing but a coulomb. Unit of charge is coulomb, and unit of time, it is in seconds or time or minutes or hours. You can say coulomb per second. Coulomb per second is the unit of current, or you can say ampere. Ampere as its symbolical, or its unit, current's unit. Now we will look forward through electric potential. What is electric potential? Electric potential is nothing but a electrical level, a electrical potential at that point. Means you can say one body is at A point and one body is at B point. The potential at A point, potential or energy or voltage at A point will be VA. It is nothing but a electric potential or force. Electric force, you can say. And for this OB, the point number B, this will be VB, nothing but electric potential at point B. Now further we will be going through potential difference. The potential difference is nothing but a difference between electric potential between 2 points. Here if you say it as 1 volt, this is about 2 volt, and this may be positive and this may be negative. When you go through Kirchhoff's voltage law, KVL, you can say at -2 plus 1 is equal to 1 volt is the potential difference between VAB, or you can simply say it as VBA because we are subtracting VB minus VBA will be VB minus VA. As simple as that. The potential between 2 points is nothing but a potential difference. Now we will be going through higher potential means higher, stronger ability to discharge a point, means it will provide you the larger energy to push the charges through this circuit. That's why higher potential, you can say that 2 volt here will be the higher potential minus lower potential, it will be giving you the potential difference at any 2 points. Now it will be expressed in voltage. It will be expressed in voltage. Now voltage will be actually work done per unit charge, means some or the other way, if you are providing the voltage to any circuit, current will be flowing through it, and nothing but that will be the work done by that circuit. As this is a closed path, closed loop, when you provide a kind of voltage to it, it induces a current, or it forces the charges to flow through it and through this element, which is the work done by this circuit. Now what is electromotive force? Electromotive force is nothing but a voltage which is generated by the source. It may be with the help of generator we are going to generate EMF, or sometimes you can say through battery also you are generating the EMF. But EMF is nothing but internal force which is which is been created actually. Now here you can say this is a terminal voltage VT, but EMF will be present in the center of it, means EMF one resistance, and then you will get this terminal VT. This is EMF and this is the resistance. That's why always EMF is electromotive force is greater than terminal voltage, because the difference of this will be VT. VT will be nothing but EMF minus this I into R, the loss. EMF will be the basic voltage generated by generator or any kind of battery. And it is a maximum voltage which will be created even under no current situation, means if you are not applying any kind of load, then to the EMF we can say EMF has maximum voltage that is produced by a element or a load when there is zero current flowing through it, or zero current in sense it may be treated as open circuit load, means you can say the load is open circuited during this, means current will be zero, as no closed circuit has been provided, because load L is equal to 0, load is 0, that's why I is 0, and this will be the EMF, the maximum voltage which will be produced during this. Now we will be going through further. Now the electric work. Electric work is nothing but a work done by the charge. The work is done by this charge. I is nothing but charge divided by T. Work done by this charge when voltage is applied to any circuit. This is work done. Work done. Work done will be nothing but voltage into Q means charge. Now you can simply say that the work done will be V into I into T. How I derive this? It is nothing but I equal to Q by T. You know, I have explained earlier. Q is equal to I into T. Substitute is in this equation. You will be getting the work done as V into I into T. V into I will be just watt and T will be seconds. Watt second is nothing but joules is the energy or work done which is produced. Now we will be going through what will be the electric power, the rate of using electrical energy, the rate with which we are using the electrical energy is nothing but a power. Power is, now I will clear this. That's why I am saying to you that you please note down each and everything while I am explaining. Even afterwards, as per your demand, I will be providing you with the most efficient notes provided by eSpark Academy, as our notes will be in a simpler language